Do you like to understand the wee sparky boys that make your computer do all those things you know and love, like play video games, word process, clicky the fishy, ran somewhere, and all those after-hour activities, like video games? Well, then Objective 13 is for you. This involves FPGA programming from Crunchy Swisher. It took me about 2.5 to 3 hours to complete, and I wouldn't have been able to do it without a presentation from Professor QWERTY Petabyte. It was invaluable to help with the challenge, as was FPGAforfun.com. Both of these were provided as a hint. Thank you so much for these hints. The FPGA module is different to programming we may be used to in that it functions and is created with a different syntax. This is based around Verilog, which is a hardware descriptor language as opposed to a programming language. And the main purpose of this is for modeling electronic systems by speeding up the process of designing and verifying digital circuits. The HDL here takes a clock signal, which is coming in as sort of a square wave from a 125 megahertz system, a frequency we dynamically set, and a reset input. The aim is to design an FPGA module that creates a square wavetone at a variable frequency. Based on this frequency, this is then used to make a doll, say the trademark phrase of this Karen, the curse doll, which is, I want to speak to the manager. Of note is that Verilog can't round real numbers to integers, and so we need to create a formula to allow this to occur. I'm not gonna lie, a lot of experimenting was involved in this challenge. As someone who doesn't specialize in modeling electronic systems, this was completely foreign to me. It's as if you have given a toddler the keys to your Lamborghini and told them to go for a drive. Not only would they likely crash it over and over, but you'd be lucky if they even got it to move in the first place without a lot of assistance. This was basically me. Try to get it to work, get help, crash it, and repeat. The help came from the Professor QWERTY Petabyte and FPGAforfun.com. I tried performing similar to both what were in these, but still had a lot of speed bumps, which is good, driving a Lamborghini. I wound up realizing that the definition for input was 31:0 and the examples I had were 15:0. This made me think this was defining a sort of an array, and one was 16-bit and the other was 32-bit. The error messages prove useful in telling me where I was going wrong, at least to a certain extent. It's as if they said, "Hey baby, you need to open the door." And then I just had to find out what open meant and find out what the door was. Of note is that all the inputs needed to be used, which were coming into the program. So at one point, when I didn't know what I was doing, I set one to basically always fail. I was checking if the frequency was 0 and nothing else, and then essentially allowing the program to continue running during my troubleshooting. I know I wouldn't get the right answer, but I needed to just try to get a wave to begin with. There was a lot of ad hoc changing numbers around to see what would happen, and in the initial instance, I just wanted any type of square wave, as most of the time it wouldn't actually run, let alone produce a square wave. When I actually started making progress, I began to look a lot at how I could calculate the numbers required for this test. I used the same logic as FPGA for Fun did and used a divider parameter to do the calculations, as this basically made sense to me with the values coming in when nothing else did. This got me to a point where I was looking at my divider parameter and realizing it needed to change within the always function. So it couldn't be static, because if it was static, it wouldn't be able to change within this function. Once the formula was split out into the always function, the frequency was being used. And the if statement of essentially having it fail was no longer required. This got me closer to the answer I needed, but I still wasn't quite there. I was essentially getting to a position where my answer was off by 10 or 100 times the value it was expecting to receive, plus or minus some strange extra data. Attempting to divide or multiply by 10 and 100 respectively failed. I was sort of just placing that anywhere in my calculations and just seeing if it would work. but I was consistently getting a bar wave at this stage, so it was an excellent start. I was starting to get into the weeds and began making tracks. I had to set an if statement to not increase the frequency if the input was a reset as opposed to something from the clock or frequency, and that removed the extra data and numbers that I was getting that threw me off ever so slightly. Once this was included, we also needed a frequency check to ensure that it was greater than 0. This in turn meant that I was always off by a magnitude of approximately 10 every single time I did this calculation. By adding a multiplication calculation by 10 to our program, this actually fixed the issue. And this is how it played out. So I'm dividing by... That's 50,000. Does that mean I can multiply by 10 here? No way. Oh my god, this is the dodgiest program. Alright, so like, I don't know why I was off by a magnitude of 10, but I managed to get the first one. So I'm going to reward myself by playing the sound that that we've created. Oh, that is so evil. All right, let's try this now. Let's try 1 kilohertz. And it works. 2 kilohertz. And it works. This random is where it's gonna probably screw up. Yep, so it's screwed up on the random. And simulating a frequency, oh, I guess. Ooh. Once I had succeeded on the fixed frequencies, the random frequency I had failed. But like the rest of my testing methodology, I decided to just run it again without changing anything and hope for the best. And would you believe it? It worked. 10. So I guess you can do that to simulate whatever frequency you want. So your model created a square wave at a frequency that is written to this percentage. So I'm slightly off. Well, actually, I love this. Using a clock frequency of 125 megahertz, the closest you could get to the target frequency is 219.99999. Instead, I got to 220.0007, which means I have a frequency that is off by that amount, and I don't know how to fix that. I guess I have to do some rounding. I don't know if this is like getting the high and low passes and that's making it slightly off when it does it a certain amount of times. All I know is that I haven't been able to Okay, I succeeded that time. Even though I failed the other time, I still succeeded that time. So I'm okay with that. So we are slightly off, but I'm okay with that because the simulation worked. Of course, no challenge would be complete without Jai stumbling around confused on if he actually succeeded or not. So let's program the device. It's been successfully programmed. Now what do I need to do? Did I win? Did I win? Is there anything else that needs to be done here? Is there another challenge I need to do? I'm actually not, like, if this is supposed to tell me I won something on KringleCon, I don't know, because it kicked me out because it took... Turns out I had taken so long to complete the challenge that KringleCon had signed me out. So I guess I'm going to close this and log back into KringleCon. This is annoying. I guess the session is still there. So let's... People are trying to use teleport. What the heck are they doing? Teleport, teleport, teleport. Let's go back into it and load it. So like, I guess we still got it loaded here. I guess we still got the same thing. So we program it, sending code for analysis, hit paused, takes several seconds. And it's been programmed. And we got the achievement this time. We did FPGA programming. Now, was that the challenge? Was that it all done, the objective? It was, we did it. We made it say in waveforms, I want to speak to the manager. Look, at this point I realized that I want to speak to the manager sounds like what the doll was producing, and well, I turned into a pterodactyl. Rip headphone users. I want to speak to the manager is... It's just that noise that was made there. But at the end of the day, we have succeeded in Objective 13.